Then architecture. Then coming to the microprocessor and microcontroller architecture, the microprocessor systems, how it will be there, we'll see. Now let's compare their architecture. In typically microprocessor system, the processor works with the external or system level micro system level memory and other supporting components. Okay. In contrast, the microcontroller integrates many of these functions inside the same chip. Here, see the difference is like the microprocessor CPU will be there. For CPU, we'll connect the external or system memory and I/O peripherals, complete computer system. This is the externals. Externally will connect. Arrow will be there means externally will connect. Then coming to the microcontroller, CPU will be there plus flash plus means all will be integrated. Okay, flash, RAM, SRAM, GPIO, timers, ADC, UART, SPI, I2C, CAN, all integrated on the one single chip. Then coming to that integration reduces system complexity. For example, if you take the microprocessor, we need to connect the all by externally, but its complexity will be increased. Then coming to the microcontroller, all will be integrated inside. The complexity will be reduced, and is one of the main reason microcontroller are popular in embedded systems. This is the main reason. All will be embedded, all will be integrated in single chip. No need to connect externally. If you want the more memory, then only we need to connect. Otherwise, no need to connect. We can use the sufficient memory or sufficient uh, components. Okay. Then coming to the memory, what is the changes? Memory is the another important different. A microcontroller commonly includes flash memory for storing the programming and SRAM for runtime data. Some sometimes E square PRAM, I mean electrically erasable programmable read-only memory, a data flash. This is the non-volatile data for storing the some uh, like some non-volatile data means if you power off on also the data will be exist. Okay. For example, your embedded C programming can be stored in flash memory, flash, while variables, stack, and runtime data is typically handled using the RAM. Microprocessor based systems can use much larger external or system level memory resource depending on the applications. These will connect externally. Okay. Then flash, if you want to connect the flash or RAM, anything, you need to connect externally. Then coming to the next peripherals. Why microcontroller are powerful for control? This is the very sorry, this is where microcontrollers becomes especially powerful for embedded applications. And microcontroller can include GPIO, timers, PWM, ADC, DAC, and communication interfaces. All will be integrated in single chip. Communication peripherals can include your SPI, ITC, CAN, CAN-FD, LIN, and depending on the microcontroller, Ethernet also will be there. Some devices. Okay. For example, in automotive ECUs, may use CAN or CAN-FD to communicate with the other ECUs. For strong statement, what I am telling, instead of building every function externally, the microcontroller gives the embedded engineer many hardware peripherals directly inside the chip. Okay, and automotive ECUs commonly use the microcontroller peripherals for vehicle networking and real-time controllers. Then coming to the next one, power cost size. These are the one of the major also. Let's talk about the power cost and size. Microcontrollers are oftenly optimized for embedded controller and low power operations. Many provide a power cost size. Microcontroller are oftenly optimized for embedded controller and low power operation. Many provide sleep and wake up modules also. This is if it is sleep and wake up, then we'll optimize the power. Okay, because many functions are integrated and microcontroller based systems can also require fewer external components. Then coming to the microprocessor based systems can require additional memory, storage, power management, and other supporting hardware also. However, remember that these are generally uh, these general it is general tendencies. Modern processors and SoC system on chip can also be highly optimized. See here, the power wise, this is a cost wise. If you come into the cost wise, microcontrollers can reduce the total complexity because many functions are already integrated. Microprocess system cost depends on the memory, power, storage, and supporting devices. Then coming to the power and cost, in both cases also microcontrollers is better choice. Then coming to the size, if I coming to the size, and microcontroller can enable a compact design with fewer external components. In modern SOS also integrated many functions. No size is applications dependent. Then coming to the size, if you take the microcontroller, everything will be inbuilt. But in microprocessor size, we are connecting externally all things. So size will be increase than compared to the microcontroller. In some system on chip also there. System on chip also this kind of the embedded systems is also all will be combined things and will deliver as a chip. That is also we'll discuss in the later slides.